All right, so for this section here, we're going to be working on getting towards being able to solve a system of equations with a matrix C. But first, we're going to review solving with elimination method. So, like I said, hopefully this is review. In the end, we're going to use something called Cramer's rule by the time we're done with this whole lesson. So if some of this doesn't click, if Cramer rule does, that's the most important thing. So solving a system equations means finding a solution for finding a solution or many solutions that satisfy all the equations in a system. So when we talk about a system of equations, that means that we have multiple equations. That was a weird way of doing that. So in this case, we have two. So sometimes you'll have three, sometimes you'll have four. Like I said, this is an example of a system of equations. So what we need to do is find an ordered pair XY that satisfies both equations. So first we're going to review graphing method and substitution method, just kind of to quickly kind of get that in your head, and then we're going to do elimination method. So we're doing a lot of review right now. I got all my stuff was in my way. Change my slide a little bit here. There we go. So if we took that system of equations, so we have, they're two linear equations. So we know they're linear because the variables just only have a power of 1 on them. So that's how we know that they're linear equations. Also, we can rewrite all of them so they're y equals mx plus b. But first one is 4x plus 3y equals 8, and then we have x minus 3y equals 7. So if we were to graph both of these, so there's my first line, there's my second line, we see they cross here at this point. So this is a point of intersection for each line. This means it's a solution for each line. So this is a solution to both equations. And since it's a solution to both equations, that means it's also going to be a solution to the system of linear equations. So my solution to this whole system is just that point 3, negative 1 1/3. So if we were to use substitution method, that means that we would rewrite one equation for one variable and then use it as a substitution for that variable in the other equation. So substitution method for solving a system of equations makes us solve one equation to one variable and then, like I said, substitute in the other. So we're using those same equations because we already know what the solution is. So what we're going to do is we're going to take this one and we just solve it for x. And then if I rewrite it, oops, plus. That's where this equation came from. So what we do is we take the next equation, and it has an x in it. So I just take this whole part here, and I just substitute it for that x. So instead of having 4x plus 3y equals 8, now I have 4 times 3y plus 7, and then I have outside that plus 3y equals 8. So what this does is this guarantees that instead of having two variables, an x and a y, which I can't solve in that case, it's going to give me everything in one variable, and I can solve for one variable. So if I distribute this, you'll have 12y. There was a little step missing here. Let me do it over here. You would end up with 12y plus 28 plus 3y equals 8. If I combine these together, that's how I end up with 15y plus 28 equals 8. I was running out of room when I was trying to do this. And after that, all we do is we just subtract 28 from both sides. I have 15y equals negative 20. So y is negative 4 over 3. Or we could rewrite that as negative 1 1/3. or negative 1.333 repeating. Now that we know what y is, what we do is we just go back to this equation and we're going to substitute that y in. So I have x minus 3 times, put that y in there, negative 4/3 equals 7. So if I go through and simplify that, we end up with x is equal to 3. So once again, I get my solution is that ordered pair where x is 3 and y, we said last time, was negative 1 1/3, or you could say negative 4/3 or negative 1.3 repeating. So what we're going to be focusing on is an elimination method, because when you do matrices are kind of doing an elimination method. It's a little more complex than that in some ways, but essentially we're setting up for elimination method. So the elimination method for solving a system of equations makes use of addition principles. So once again, I got those same two equations. So according to these equations, x minus 3y and 7 are the same answer. That means I can add x minus 3y to the left side of the equation and 7 to the right. Trying to get that to fit in there. Sorry about that. My slides wasn't moving forward like it was supposed to. So what I mean by that is that this is equal to this, meaning I can take this whole equation here and add it to this side. And I can take this 7 here and add to this side, and I'm adding the same thing to both sides. So kind of what we do is we just set it up like it would be addition. And we know that we are going to add this and this together. So we got 4x plus 1x, that's going to give me 5x. We have plus 3y plus a negative 3y, which is going to leave me with 0 y's. So this could really just be 0. And then the same thing here, this is still plus. I have 8 plus 7, that's going to give me 15. So this is going to result in an equation that is just 5x equals 15. Well, if I go through and I simplify that, I just get x is equal to 3, like we've been saying all along. We know one of our solutions to the system is x is 3. Now we just need to find y. So I'm just going to pick one of my equations. It could work for either. So if I pick 4x plus 3y equals 8, I'm going to take that and I'm just going to substitute that 3 back in here. So now I'm going to have 4 times 3 plus 3y equals 8. 12 plus 3y equals 8. I solve for y. Let me bring that down here. I solve for y. And we are going to get a negative. Yeah, sorry, I was missing a spot here. We're going to get a negative 4/3. And like I said, it didn't matter which equation I used. I could have used this one with my x equals 3 instead of this one here. And I still would have got the same result. So you just pick one of them. But like I said, the focus right now is that we pick this one. So what you could do is once you get that paired, just to make sure it worked, just substitute it back in the equation that you didn't use. So we used this one first. If I substitute back in number 2 and it works, which we just showed that did, then we know we got it. So like putting in that x equals 3 into both equations is just verifying that everything was working correctly. Because I end up with the same y. Okay, so this is just checking that the solution was correct. So when deciding which variable to eliminate, we inspect the coefficients in both equations. If one coefficient is a multiple of the coefficient of the same variable in the other equation, that is probably the easiest variable to eliminate. So just to go back here, I didn't have to try to do anything special here. I had a 3y and a negative 3y. A variable was instantly going to eliminate if I add those together. But if a case like this one here, where I have 2x plus 5y equals -1 and 3x minus 10y equals 16, it might be a little harder to figure out how am I going to add those together, because if I add those as they are, I ended up with a 5x minus 5y equals 15. Doesn't give me a lot of help here because I still have an x and a y. And the point of elimination method is we're eliminating a variable because we just want one variable because I can solve for one variable. So let me erase something here for a second. I'm trying to make sure it's gonna be this box here. Give me the wrong color. So let me get rid of this and kind of show you what I'm talking about here. So like I said, if one coefficient is a multiple of the of the same variable in the other equation, what we can do is this. So we notice with these two, I get a -10y and a 5y. So this is a multiple of my 5y. So what I can do, because this keeps the same equation, is I'm going to take this one and I'm just going to multiply everything by 2. So you think of it kind of like this, is that I'm just multiplying this side by 2 and this side by 2. This is going to give me an equivalent equation. So everything is fine. Remember, as long as I do the same thing to both sides, we're good. So I'm just going to change that to a 4x plus 10y equals -2. This one we're not changing, we're just bringing it back over here. But what you see now is that if I try to add these equations, I'm going to make y disappear. Now I have 7x is equal to 14. And easily I can say, oh, well, then x is equal to 2. So always use one of your original equations. So if I was going to take this to plug it back in, let's say I want to use the first equation. I want to use the first equation in its original form. Just in case you make a calculation error, you don't want to keep making that error worse and worse. We're going to take that 2 and substitute in here. So now I have 2 times 2 plus 5y equals -1. So I have 4 plus 5y equals -1, which is going to be 5y equals -5. Y is equal to -1. So my solution is going to be 2, -1. And like I said, we could check with this equation here if that's true. So I'm just going to put that point in here and make sure that I get a true statement. So I get 6, -1 times 1 is 10. 16 equals 16. Yeah, that was a point that worked. This is one of the things, like I said, that we like about elimination method is that sometimes I can avoid some really messy stuff by just simply doing something like I did here. I just multiplied this whole equation by 2. This equation in this equation are equivalent to each other. Just one, everything, all your coefficients are doubled. And then we can go through, we can do that elimination method. So this is another example that we have. So one of the things you always want to make sure, I can leave it like this. I just want to make sure that my X variables are lined up together, my Y variables are lined up together, and then these constants are lined up together. As long as it's lined up like this, I'm fine. Same thing here. We were okay with the way we did that because X's were lined up, Y's were lined up, your constants are lined up. So in this case, we're looking at it, we're trying to decide what we're going to try to eliminate. So you can go, well, I want to try to get rid of the X's. I can want to try to get rid of the Y's. So I'm just going to say, we're going to eliminate Y. We want to figure out how am I going to make that happen? X and Y, one's not going to be any easier than the other because as you see, now these are a multiple of the other. We got 2 and 3. Here we got 3 and 5. Now there's a multiple of the other. So another thing that we can do is we can multiply both equations so that we can eliminate a variable. So because I got 3 here and 5 here, one of the easiest things I can do, I'm going to take this first equation and multiply both sides by 5. And when I do that, I'm going to get 10x is equal to, let me go back and fix something here. There you go. Both sides like that. So we get, this goes here, then this distributes here. So we get 15y plus 10. So this is still equation number 1. Now the second one, we see I got a 15y here. So we want to make sure this is a negative 15y when I multiply it by something. So I wouldn't just multiply by 3 because I have 3 here. I use negative 3. Because now if I do that, I get a negative 9x here. If I do the negative 3 on this side, like I said, now I get a negative 15y, so now I can make the y eliminate. So you're just trying to think, what can I multiply to make a variable eliminate? Okay, now that we got that, and like I said, this was our equation number 2, it's just rewritten. If I add my x's together, I'm left with x. If I add my y's together, those disappear. If I add my constants together, I'm left with a negative 2. So here I get x is negative 2. Now I just pick one of my equations. I just pick the original version of it. And I'm going to substitute that negative 2 in for the x. And we just solve for y. So if I subtract negative 2 from both sides, I have negative 6, 3y. Y would be equal to negative 2, or if you don't like it that way, y this way. And now we have my solution to negative 2. And like I said, you may want to check it here just to make sure that it did work. Check, I can move something away on my screen. I'm going to do my little check here quickly. So I had 3x minus 5y plus 4. If I substitute my negative 2 in for x, and then my negative 2 in for y, we're going to see if this works for us. So this is a negative 6. This is a negative 10 plus 4. Negative 6 equals negative 6. We found the right solution. All right, so take a moment and try this on your own. Like I said, you may be a little bit of struggle, but attempt it and then come back to this. But you should have questions 1, 2, 3, 4, and 5 on your worksheet. After that, the other ones are special cases that we're going to have to talk about in a separate video. Okay, so for number one here, this one is actually pretty easy. We don't have to multiply by anything because we have an x and a minus x. So those will cancel each other out. So this is going to be like our first time that x actually cancels out first. So like I said, just make sure x's line up, y's line up, constants line up, equality signs in the right place. We got to make sure that equality sign is also lined up. So let's add these together. X plus negative x is going to be 0. Negative 7y plus 2y is going to be negative 5y. And negative 3 plus 18 is just going to be 15. So if we solve for y is just negative 2. So just pick one of those equations. I've just been picking the top because out of laziness. And then we said that y was supposed to be negative 2, so we're just going to substitute it in. All right, and then we're just going to solve for x. And we're getting x is equal to 17. Except I made a mistake. Just a second, let me go back. This was a silly mistake to make. So let's just fix it here. All right, this would have been 3. That makes a little more sense. So we're substituting in with a negative 3. That's 21. And then we get negative 24. So like I said, just to kind of check it, make sure it worked, which is how I caught that I made a mistake, because I went back and checked it. So the other equation, so that x is now replaced with a negative 24. So negative 24 plus 2 times negative 3 equals 18. 24 minus 6, which is going to be 18 equals 18. Like I said, this is my check. So I did find my solution. So my solution is the point negative 24, negative 3, because that will work for both of those equations. All right, so this one may have tripped you up, and that may have been a little on purpose because we're going to end up with a 0 in here. So we just wanted to discuss that. So once again, x is lined up, y is lined up, equal signs lined up, constants are lined up. Everything is lined up the way it should be. So you may have noticed, nice new color here to make this pop. Those two numbers are, one of them is a multiple of the other. So if I just multiply the 2y by 4, I could cancel out that negative 8y, because then I'd have a positive 8y. So it's the second equation. All I have to do is just multiply by 4 here and by 4 here. So the first equation stays the same. So this is equation number 1. Equation number 2, we distribute this 4, we get a negative 16x. And then, sorry, negative 16x plus 8y. And then this is going to equal 12. So this is my new number 2. If we add those together, we get a positive 7x plus a negative 16x. So that should leave us with negative 9x. Then this is going to be negative 8y plus 8y. That cancels. Negative 12 plus 12, that cancels. So there is a solution to this still, because the only thing that x can be to make negative 9x be 0 is x would have to be 0. So hopefully you caught that. I know sometimes that trips people up, but just wanted to point that out. So if you have your variable, no matter what's multiplied by, equal to 0, then that variable itself has to equal 0. So let's take that first equation again. And now we have that x would be 0. We're just going to stick that in there. So we're going to have 7 times 0 minus 8y equals minus 12. Negative 8y equals negative 12, meaning y equals, when we divide this, a positive 12 over 8, because those two negatives will cancel. Right? Because I got two negatives, they're going to go away. Those also can be reduced. Both of them are divisible by 4, so we'd end up with 3 over 2. Now, if we just do the quick check, we use the other equation. So negative 4 times 0 plus 2 times 3 over 2 equals 3. So that's going to be 0. Those cancel, and we're just left with 3. 3 equals 3, so it was correct. So my solution to this system of equations is x is 0, y is 3/2. All right, so for number 3, like I said, x is lined up, y is lined up, equal signs lined up, constants lined up. So as we see, none of these are like a multiple. So I'm just going to pick something to eliminate. And I'm just going to eliminate x this time. If you did y, that's fine. Hopefully we both get the same answer, but I'm going to do this with x. So what I can do is, because this is 2 and this is x, is I'm going to multiply everything here by 7. And then the second one, I'm going to multiply it by 2, but I want to make sure that one of these is a positive and one of these is a negative. So I'm just going to decide I'm going to multiply by negative 2. So the two equations I should end up with is, as I distribute this, is a 14x plus 21y equals 140. I distribute this negative 2 across here, and I get this new equation. Then it's a negative 14x, so that's why I use that negative, because now my x's are going to eliminate. Negative 4y, and negative 2 times 53 is going to be a negative 106. So if I add those, my x's disappear. I'm going to have 17y, and then I'm going to end up with 34 here. So 34 divided by 17 is just going to be 2. So we already decided or found out y should be 2. So just pick one of those equations and substitute the y for 2. So I picked number 1. I'm just substituting in here. So as I solve for x, what we should find is that we're going to end up with x being 7. And just to double check, we're going to use that third equation to make sure my point's correct. So 7x, and x is supposed to be 7 as well, plus 2y, y is also 2. So we get 49 plus 4, and that in fact does actually add up to 53. So we have the correct points. So my solution is going to be 7, 2. All right, so this one itself is an interesting case. So we have, let's say we want to try to eliminate, doesn't matter which one we pick, but let's say we try to eliminate the y's. So we got a negative y and a negative y. All I really need to do is take one of these equations and multiply by negative 1. So then I'd have a negative y and a positive y. So if I do that to the top one, I'm going to have negative 2x plus y equals negative 1. So that's my first equation. The second one is unchanged. You may notice there is a big problem here. So my x's eliminate, my y's eliminate, and then I'm just left with a -4 here. So I get 0 equals -4. This is something that cannot happen. What we have here was something that are two parallel lines. Trying to think how it would look. So you have, I think this is your line number 1 would look like this, and then your line number 2 would look like this. These are two lines that don't actually cross. So this is why you end up with something like 0 equals -4, which we know cannot happen. This means we have no solutions. So not every system of equations is actually solvable. So I left that one for you to see if you find catch on. It's like, it's not working. Not everything works. All right, so number 5 is another unique case. So same thing here. Let's say we tried to do y last time. Let's try to eliminate x. So we notice between our x's that if I just multiply all this by 3, or -3 anyway, this would turn into a -9, and I can cancel those x's out. So if I go through that, I get a -9x minus 12y would equal -15. So that's number 1. Number 2 is 9y plus 12y. So it shows 9x plus 12y equals 15. I'm trying to write and talk, it's not working. In this case, that's a 0, that's a 0, that's a 0. But we get 0 equals 0, and that is a true statement. So what you have here is that both of these are equivalent lines, or essentially the same line. So they're equivalent equations. Which means that they are the same line if we graph them. So basically it's like we would graph one of them, and then the other one would go directly on top of it. They're exactly the same. So that means that we have an infinite amount of solutions, because if a pair of points is a solution for one, it's a solution for the other. So we have infinite solutions. So like I said, any point that is a solution to one line or equation is a solution to the system. So this is a little different than being all real numbers. It's a particular combination of real numbers because it has to be ordered pairs. So sometimes when you'd see like the set notation for this, it's an XY pair that satisfies one of your equations, and you just put in that equation. It just has to satisfy one or the other, but it'll satisfy that whole system. All right. So just finishing out little special cases. When solving a system of two linear equations and two variables, if a false equation is obtained, such as 0 equals 7, then the system has no solution, like we had saw in number 4. The system is inconsistent, meaning that really it doesn't work together, and the equations are independent. So the equations are different from each other. That's what independent means. Consistent means that we couldn't find a solution. If a true equation is obtained, such as 0, 0, then the system has an infinite number of solutions. And I think I spelled infinite with an A earlier, sorry about that. The system is inconsistent and the equations are independent. So independent basically means that they're the same equation. Consistent means we have a solution. Finite solutions. So when you hear the word finite solutions, in most of our examples, so 1, 2, and 3, we had one solution. In a system of equations, if a system of equations, there we go, has finite many solutions, so not infinite, meaning that we'd have one solution, just two solutions, just three solutions, but there is a definite number, then the system is considered consistent because it has solutions, and the equations are independent because they give you different lines. So this here was just for you. So just how to go through solving a system of equations. If you had any decimals or fractions, you would always want to clear those first. We're going to try to avoid giving you too many of those. Choose a variable to eliminate. So like I was always picking X or Y. Make the chosen variable's terms opposite by multiplying one or both equations by the appropriate number. So like I said, so if one was like 15x and then the other one was 3x, and multiply the other one by a -5. So I have a 15x minus 15x. So we just want to make sure that the variable I'm choosing to eliminate, we can make their coefficients opposites. Eliminate a variable by adding the respective sides of the equations and then solve for the remaining variable. And then substitute either the original equation in either of the original equations to find the variable of the other. So like I said, it's just kind of a walkthrough of what we did. And then this is just for you here, strengths and weaknesses of graphical and substitution and elimination. Graphical, you can see your solutions. It's really inexact because you're just trying to pick a point on a line and make kind of a guess of what the value is. Substitution gives us exact solutions. It's convenient when the variable has a coefficient of 1. When you have more coefficients, it becomes a little more difficult to deal with. It can cause extensive computations when we have fractions and you can't see the solutions quickly. Elimination, its only weakness is you can't see the solutions quickly, like graphical. It yields exact solutions. It's convenient when we have coefficients other than 1 as a preferred method for systems of 3 or more variables of equations. So we're only doing 2 right now, but if you in the future did 3, elimination is much easier to use for that. So it's out of all 3, probably the best way to solve a system of equations.